What if you could build your own bright, adjustable bicycle turn signals using just one tiny chip? Hey guys, in this video, I'll show you how to build bicycle turn signals with a 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 3 alligator clips, a 3-position rocker toggle switch, 26 jumper wires, 468 ohm resistor, a 1 kilo ohm resistor, a 4.7 kilo ohm resistor, 12 red LEDs, a 9-volt battery buckle connector, a 9-volt battery, 1555 timer IC, a 100 kilo ohm potentiometer, 110 microfarad capacitor, 110 nanofarad ceramic capacitor, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Bend the ends of a 1 kilo ohm resistor. Insert a 1 kilo ohm resistor into pin 2 or trigger in a few rows above the 555. Insert a 10 microfarad capacitor into the same row as the resistor in the negative rail. The cathode is in the negative rail. Bend the ends of a 4.7 kilo ohm resistor. Insert a 4.7 kilo ohm resistor into pin 7 or discharge and the positive rail. I'm going to arrange the 3 wires for this potentiometer. Insert a jumper wire into pin 6 or threshold and a few rows below the 555. Insert a jumper wire into pin 7 or discharge and 2 rows above the previous wire. Insert a jumper wire into pin 6 or threshold and 4 rows below the previous wire. Insert a 100 kilo ohm potentiometer into the same rows as the previous 3 wires. Insert a jumper wire into pin 5 or control in a few rows below the 555. Insert a 10 nanofarad ceramic capacitor into the same row as the jumper wire in the negative rail. Insert a jumper wire into pin 3 or output in a few rows above the 555. Bend the ends of a 68 ohm resistor. Insert a 68 ohm resistor a few rows above the jumper wire. Insert a red LED in the same row as the resistor and 2 rows above it. The anode is in the same row as the resistor. Insert another red LED above the previous one. Insert another red LED above the previous one. Insert a jumper wire into the same row as the last LED and the negative rail. Insert a jumper wire to connect the two LEDs. Insert a jumper wire to connect the two LEDs. Insert a jumper wire to link the 68 ohm resistor on the left side of the breadboard to the right side. Bend the ends of a 68 ohm resistor. Insert a 68 ohm resistor a few rows above the jumper wire. Just like before, insert a red LED in the same row as the resistor and 2 rows above it. The anode is in the same row as the resistor. Insert another red LED above the previous one. Insert another red LED above the previous one. Insert a jumper wire into the same row as the last LED and the negative rail. Insert a jumper wire to connect the two LEDs. Insert a jumper wire to connect the two LEDs. Just like before, insert a red LED in the same row as the resistor and 2 rows above it. Just like before, arrange and connect the red LEDs. Insert a jumper wire into the same row as the 68 ohm resistor above the 555. Connect the other end of the jumper wire to a red alligator clip. Insert a jumper wire into the same row as the 68 ohm resistor below the 555. Connect the other end of the jumper wire to a red alligator clip. Insert a jumper wire into the same row as the jumper wire connected to pin 3. Connect the other end of the jumper wire to a black alligator clip. The 3-position rocker toggle switch supports 2 on and 1 off positions. Attach the red alligator clips to the sides of the terminals. Attach the black alligator clip to the middle terminal. Connect the 9-volt battery buckle connector to the 9-volt battery. It's time to connect the power supply. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. Press the switch to the left to turn on the left signal lights. Turn the potentiometer knob to the right to make the LED blink faster. Press the switch to the middle to turn off the signal lights. Press the switch to the right to turn on the right signal lights. Let's dive into the circuit and break it down step by step. This circuit uses a 555 timer in astable mode to generate a flashing signal for bicycle turn indicators, and the flash rate is fully adjustable with the potentiometer. The 555 timer continuously charges and discharges capacitor C1 through resistors R1, R2, and R3. As C1 charges, the voltage across it rises. When that voltage reaches 2/3 of the supply, the 555's internal comparator triggers pin 6 or threshold pin, switching the output at pin 3 low and allowing pin 7 or discharge to quickly discharge C1 through R2 and R3. When the capacitor voltage falls to 1/3 of the supply, pin 2 or trigger flips the output high again, and the cycle repeats. This constant charge-discharge cycle produces a square wave pulse at pin 3, which becomes the flashing signal for the LEDs. The flash speed is controlled by R2, the 100 kilo-ohm potentiometer. Turning the knob changes the resistance in the charging path, which directly affects how long C1 takes to charge. Higher resistance means longer charge time, slowing the blink rate. Lower resistance speeds up charging and produces a faster flash. R1 and R3 set the lower and upper limits, ensuring the timer remains stable and preventing the potentiometer from reaching a dead zone where the circuit stops oscillating. C2, the 10 nanofarad capacitor on pin 5, filters noise from the control voltage input, keeping the 555 output clean and consistent. The output from pin 3 does not go straight to the LEDs. Instead, it is routed through a 3-position rocker switch, SW1. This switch determines which set of LEDs receives the flashing signal. When SW1 is centered, pin 3 is disconnected and no LEDs flash. When the switch is flipped to the left, the pin 3 output is routed to the left side LED array through resistors R6 and R7. When flipped to the right, the output is routed to the right side LED array through resistors R4 and R5. Each LED group has its own series resistor to set the correct current for the LED strings, ensuring equal brightness and preventing damage. Once the output signal reaches a chosen side, all LEDs on that side blink in unison at the rate set by the timing network. The LEDs are arranged in vertical stacks to give a bright, attention-grabbing directional signal that mimics automotive-style turn indicators. The 9-volt battery powers both the 555 circuit and the LED arrays, making the system compact and ideal for bicycles. The overall result is a simple, reliable, and adjustable flashing turn signal system, controlled by a single 555 timer and a rocker switch. I hope this video has shown you how to make adjustable flashing bicycle signals with a 555 timer IC. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Don't miss it. Click the link in the description to get yours. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.